Let's talk about throwing things at an angle. Let's suppose that an object is thrown from an initial height of 80 feet, that's the same, with an initial velocity of 64 feet per second, at an angle of 60 degrees above the horizontal. So we're not throwing the object directly upward at 64 feet per second. Seems dangerous, might come and land on our heads. So we're going to throw it at an angle, 60 degrees above the horizontal. So what that means is that our 64 feet per second is not all upward velocity. In the previous problem, we had all 64 feet per second going directly up. Now we're throwing 64 feet per second at an angle of 60 degrees above the horizontal. So what we're looking at, if we imagine the horizontal here, and we have 60 degrees above the horizontal. So here we have a 64 feet per second at 60 degrees above the horizontal. So some of our velocity is upward velocity, but some of our velocity is horizontal velocity. We have two components. We're going to break the velocity into two components, a horizontal velocity and a vertical velocity. And we're going to do that with a right triangle. So here, some of our velocity is going up, and some of our velocity is going side to side. No, we're starting from a height of 80 feet. Yeah. So what's happening is we're up at a height of 80 feet, and we're going to throw something up at an angle, and it's going to come down onto the ground. So some of our 64 feet per second is not is going horizontally, and some of it is going vertically. We're going to break it up with a right triangle. So the vertical upward velocity, that's going to be opposite. The horizontal velocity is going to be adjacent. And the 64, our initial 64 feet per second is the hypotenuse. And our angle theta will be 60 degrees. And we'll just use our trig ratios. So our vertical or upward velocity is going to be 64 times the sine of 60 degrees. Not all of the 64 is going up. We're only going to get sine of 60 as a fraction of our upward velocity. So we get 55.4. feet per second. Our horizontal velocity, which might come up later, we're not going to have all horizontal as well. We're going to have 64 times the cosine of 60, because this is adjacent to the 60-degree angle. $32. So now we have two things that we're going to go after. We're going to look at the height of the object at t seconds after being thrown. I need the upward velocity, so the 55.4 is what I'm going to use for my initial upward velocity. I just want the upward part of the velocity for the quadratic. Now I've got this 55.4, which is not convenient for factoring. It's not going to be factorable. So maybe we want to solve using the quadratic formula. It's also not conducive to completing the square. So we're going to skip completing the square, and we're going to go to the end result of completing the square, which is the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to use my calculator, and since I'm going to be solving, I'm going to want to tell my calculator what the quadratic formula is. So unfortunately, I have not got that stored in my calculator, so I'm going to go write a program. And I'm going to call my program quadratic formula. So programming on your calculator is pretty straightforward. You just have to know where the buttons are. The first thing we need to do is have the calculator ask us for A, B, and C. So if I go to program and IO for input and output, I can have the calculator prompt me for alpha A, comma, alpha B, comma, alpha C. What this will do is the calculator will say, what's A, what's B, and what's C. We just drop those numbers in. Then we're going to have it do the quadratic formula. We can go right to the answer, so we'll go program input, output, display. Then I'm going to plug in the quadratic formula, but I have to do this in single line. I'm going to have to do 2 lines, 2 entries, because there's plus or minus, and we can't have the calculator doing plus or minus. We have to pick one. So first, I'm going to display parentheses, the opposite of b plus the square root of b squared minus 4ac. Close the square root, close the numerator. Then we'll divide by, open the denominator, 2a. If we can make this a fraction, let's make it a fraction. So in the math button, the first entry is convert this to a fraction, if we can. You won't be able to. That's the negative b plus the square root. I also need to be able to do negative b minus the square root. So I'll hit enter for a new line and display
negative b minus the square root of b squared minus 4ac. Close the radical, close the numerator, and divide by, open the denominator to a. Close the denominator, and if possible, convert that to a fraction. Yeah. Prompt is under, hit the program button, and go to input output, and the second one is prompt. Now to run the program, go to your program menu again, and notice that QF, our new quadratic formula program, is there in the execute menu. So we execute it. That brings this program to the front. It's blinking at the end, so it says I'm ready to run. Hit enter, and it says A. A is negative 16. B is 55.4. And C is 80. And it barfs out our answer. So convenient. If you want to use more fancy things, if you run it again, it's negative 16. This was actually 64 times the sine of 60. And C was 80. So if you hadn't written down the 55.4, it can actually do the calculations as B. But it's just prompting A, B, and C, and then displaying the two values. We asked for fractions, but since the answers were irrational, it was not able to display fractions, so it just skipped that part of the command. Any questions? Yep. Yep. So if you want to fix it, you can go to edit. This is about as short as you can make a quadratic formula program, so that's why I like this one. Yeah, find quotation mark. The modified version of the quadratic formula program. This quadratic formula, Ric Flair edition. Now, if you run it, negative 16, 5.4, 80. And you go, woo, at the end. Any questions? That's our okay. Now we've got a recording on the YouTubes of program the quadratic formula on your calculator. This is the shortest one. Pre-Ric Flair edition, this is the shortest one. That displays things as fractions. We want to make sure that we have the fraction one in case you've got like, let's say 2, negative 7, and negative 4. Because then it'll give us a negative 1/2 and a 4 rather than 0.5. Any questions? Comments? So this is just in addition to the problem that we've done previously on projectile motion. If we throw something at an angle, then we have trigonometry. We break that into two pieces, a vertical velocity and a horizontal velocity. Where the horizontal velocity might come in useful, notice that it looks like the object lands at 4.55 seconds after being thrown. So that's just going up and then down. So 4.5 seconds out, it's up in the air. That's when it reaches its height of 0. It's going forward at 32 feet per second for 4.55 seconds. So if we want to know how far the object went, we just take our horizontal velocity, 32, and multiply by how long it's in the air, 4.559186803. So it will fly 32 feet per second forward, but only for 4.55 seconds. So it has a range of 145.9 feet. So it'll go up to a map. We can figure out its maximum height when it reaches there, when it lands on the ground, and how far it will go forward, since we have some horizontal velocity now. Before, our velocity was all vertical. Any questions? Comments? How's everybody okay? We should do this with a lab and like go up to the roof and like throw stuff off the building, but then they get all mad. If I'll stop throwing light bulbs off the building, leak. I'm like, oh, fine. Like, ow, hey, stop throwing vodka bottles off the roof, leak. Where'd you get all those vodka bottles? I don't know, they were up here on the roof where I drink my vodka. I mean, where someone was drinking vodka. I'm just kidding. I don't drink vodka. What am I, frat boy? I'm just kidding. I'm not an alcohol snob. If you like vodka, drink vodka. Although if you're drinking vodka straight, I mean, get help. Any questions? Comments? It's not enough. Yeah. Oh, you need the most important part of the program, Ric Flair edition. You've got to go to input output. So display for that, but to get actual, oops, the wrong button. You got to put it in quotes. Whatever, if you wanted to just display some words, you put it in quotes. Quotes are above the plus sign. And it's in green, so alpha, quotes. And then you can type your message here. If you want to, you can also alpha lock if you're going to type a message. And then you can type your message. Unfortunately, it doesn't have a QWERTY keyboard. It's got an alphabetic keyboard. And that slows everybody down so much. So it takes a long time to type stuff because it's in order. It would be fast, except we rearranged the keyboard, and so now we're all used to this messed up QWERTY keyboard. There's also a space, so you can be like, oh, can, and the space is down here on the 0. And you can be like, oh, you, space, smell. I mean, this is the important part. I'll put that for now, because now you got to be careful because it just will just display these in order, right? So, like if you put in like the whole thing, can you smell what the rock is cooking? Might cut off one of the words and just wrap it around. So you'd want to put it on different lines. So make sure you put it on different lines. Also, if you put it on different lines, oops. You can make it more dramatic. put it on different lines, and that'll add some more drama to your message. All right, that's the thing that we needed today. We're gonna, if we have a velocity, we want the upward part. We're just gonna draw a triangle, and we're gonna break into components, our horizontal and vertical components. All right, that's gonna do it for today. I will see you all on Wednesday. Everybody have a good couple of days, and thanks for playing.